Hello, my name is Mel Slater. Thank you for inviting me to speak at this meeting. I'm sorry, as I guess as is everyone, that we can't all be there together. So I'm going to talk about practical illusions of virtual reality, and there are three main illusions which I'm going to talk about. The first one I call place illusion. You're in a virtual reality, and it's the illusion that I'm here, I'm in this place, which is depicted to my senses through the virtual reality systems. And what is this based on? It's based on natural sensory motor contingencies for perception. By that I mean you use your body to perceive as you do in everyday life. If you want to look behind an object, you move your head. You can look underneath things, you can bend down, you can reach out and touch things and so on. To the extent that these sensory motor contingencies are supported, that's the extent to which you may have the illusion of being in the virtual place. The second illusion I call plausibility, and this is the illusion that the events are really happening. Place illusion is about where you are. Plausibility is about your response to what's happening. And this seems to depend on at least three factors: how responsive the environment is to you, how personal it is to you, and how much the events that happen are congruent with your expectations if the environment depicts something that could be real. The third illusion is a body ownership illusion. This is the illusion that when you look down and you see a virtual body substituting your own, that you have the illusion that it's your body. And this is based on appropriate multisensory integration, as we'll speak about in a few minutes. The first illusion, the place illusion, is a perceptual illusion, and it's persistent. It's persistent in the sense that if it breaks for some reason, then it reforms again after a while. Plausibility is more of a cognitive illusion. If that illusion breaks, it doesn't reform again. Basically, you lose interest in what's happening. The third one is again mainly a cognitive illusion, mainly a perceptual illusion. This again is persistent. If it breaks, it comes back again. So my hypothesis is that these illusions, pi, which is place illusion, and psi, which is the plausibility illusion, when these two things operate together, you have realistic responses to situations in events in the virtual environment. And by realistic responses, I mean at the physiological level, the behavioral level, emotional level, and cognitive level. And we'll move on to an example of this now. So this is an example from social psychology called the bystander effect. Here we study how people respond to violence, and experimentally this is something very difficult to do because experiments with real people in the context of violence is just not ethically possible or practically possible. But if people respond realistically in virtual reality, then you can do it. So we can face people with violence in a virtual reality and observe how they respond rather than just give them a questionnaire about how they think they might respond. So this study was based on soccer violence, and all the participants in our study, which was carried out in London, were supporters of the Arsenal Football Club. In their situation, they were in a virtual bar and someone talked to them about the Arsenal Football Club. That person could either be another Arsenal fan, a virtual person, by the way, another Arsenal fan, or a neutral football fan. There were other people in the bar, and they themselves are either Arsenal supporters or again neutral football fans. Then something happens. So this was filmed in a cave system.
Yeah, hello. Yeah, I'm good. How are you?
Our subject is talking
I'm from North
to
London
an
originally.
Arsenal supporter in this case,
Really?
and they're
Yeah.
just talking stuff about
You're Arsenal, yeah?
how
Yeah,
much
of
they
course,
like
yeah.
football, Arsenal, and so on.
What did you think of the team last year?
So
It
there's
was good. They
rapport
could have done
building
much better, but
between
I mean, the team was okay, yeah.
the subject and the virtual subject, the virtual
What did you
character.
guys go to the match?
Notice
Well,
another
I'm
guy
waiting for
has
my
come to
season
sit
ticket,
in the
but
bar.
I try and go whenever I can.
So let me wind this forward a bit. This conversation
Playing with
carries on for a
Arsenal,
while.
like 5 years ago.
Yeah.
Henri, Vieira, Pires, that was a hell of a team.
Yeah, it was.
and notice
Find one
him.
that's better
Oi.
than...
You got a problem?
Sorry?
I said, have you got a problem?
No, mate.
Yeah, well, I saw you looking at me.
I didn't look at you.
Well, I saw you. I saw you staring.
No, we were having a
No,
conversation.
I wasn't staring at you, mate.
Something to get off your chest.
No.
You sure about that?
There's nothing wrong, mate. There's no trouble here. I'm just trying to enjoy a quiet pint. Just
Yeah, well, that's what I was doing. Enjoying a quiet pint.
go back to your table, enjoy a quiet pint. We're back down.
Tell me to go back to my table.
Not
So this confrontation continues. The blue one becomes more and more aggressive, and the one in red, the Arsenal supporter, however much he tries to dampen down the situation, it seems to get
You
worse
actually
and
support
worse.
Arsenal. What
Yes,
the,
I'm an Arsenal
when was
fan.
the last thing they won?
Doesn't
When was the last
matter.
thing they won?
Doesn't matter.
Yeah,
I haven't asked for
nothing.
any
Nothing.
trouble.
No.
And it gets worse and worse.
You
Calm
leave
down. There's
now.
no need for this.
Well, take your pint and f*** off.
Why?
Notice there's
You're
another
offended.
bystander
That
join
shirt
them
offends me.
now.
Hold on. Take it off and you can stay in.
I'm not going to
take it
my
off and
shirt.
have a drink.
I'm not going to
Take
take
the
it.
fucking shirts off.
Leave it, though.
Listen, just calm down.
What's going on
There's
here?
no problem.
You told me
What
to
have I
leave.
done?
So what happens? If the virtual man who talks to you is an Arsenal supporter, the one who talks to you at the beginning, the one who's actually attacked, then you're more likely to intervene to stop the argument. If the other people there are Arsenal supporters, you're less likely to intervene, because it's kind of like saying, why should I be the one to intervene? Let them intervene. So your identification with the victim leads you to want to help. They're an Arsenal supporter, you're an Arsenal supporter, you want to help your fellow Arsenal supporter. But if others with the same identity are there, you leave the responsibility to them. And you might think, well, kind of it's obvious. Yeah, it's obvious, but this is virtual reality. Nothing really is happening. So how is it possible that people get upset in this virtual scene and they try to intervene to stop a fight between non-existing people? For this to happen, participants must have the illusions that first, they're in a different place. This is the sensory motor contingencies leading to place illusion. And second, that the events are really happening, that their responses lead to plausibility, the responses of the system lead to plausibility. And this is in spite of knowing these are illusions. So presence can lead to realistic behavior. It doesn't matter that you know that they are illusions. You just can't help responding. At some level, the brain doesn't know about virtual reality and it just responds. And actually, this is the safe computation for the brain to make, that these events are really happening, because they might be. As I said, at some level, the brain doesn't know about virtual reality. It just responds to sensory input. So I have a strong view about place illusion. This is the strong illusion that you're in the virtual place in spite of the fact that you know that you're not there, that this is not real. This is not to be confused with many interpretations of presence that there have been given over the years, such as attention, interest, flow, task performance. For me, presence is purely the illusion that you're in a place where you know you're not. So in this definition, place illusion is not applicable to our normal everyday experiences. The fact that it occurs is witnessed by the surprise that people have when they put on the head-mounted display and suddenly they're somewhere else, and then they make adjustments to their perception afterwards. So they get surprised, where I mean surprised first of all in an ordinary everyday meeting. It's a perceptual shock to go into a cave or put on a head-mounted display and suddenly you're somewhere else. But it's also surprise in the technical meaning, in the meaning of entropy, where we need to minimize surprise to be able to function in this new environment. So here's an experiment we did several years ago, minimization of surprise. In this experiment, participants experienced a gradually forming virtual environment, and the way this was done was that polygons were just appearing apparently at random, and there were three conditions. In the stress-inducing condition, participants found, after all the polygons had formed, or some percentage of them, participants realized that they were standing on top of a column, a tall column. In the non-stress condition, it was exactly the same. Participants were in the same environment, but the column was at ground level, so they weren't standing high up on a column. In the random one, the same polygons were used, but they were randomly rotated, So the environment in the end never came to mean anything. And what we measured was head gaze direction entropy. So we measured the scan paths of the head gaze direction and calculated its entropy, and then also skin conductance responses. And the results were very interesting. If we look at, on the horizontal axis here is the time, and the vertical axis is the scan path entropy in the solid line, and the skin conductance responses in the dotted line, then we can see scan path entropy gradually declines as the environment forms, but just around the point when the environment is known, in other words, when the environment's random, you're moving your head around a lot and your gaze direction is changing kind of at random. But as the environment forms and you understand what it is, the entropy of your head movements goes down. Just at that point is where the skin conductance results, the skin conductance responses increase because you realize you're standing on top of a column. Whereas in the no entropy, in the no stress condition, that doesn't happen. You see the environment gradually forms as before, and the entropy tends to go down, but there is no change in skin conductance responses. In other words, just at the point you realize you're standing at the top of the column, the entropy goes down, the surprise goes down because you know where you are, but the shock goes up because you're standing on top of a column. But in the non-stress condition, it doesn't work the same way. This is another example. The cross lines are the cross lines are in the first period of the experience, and the circle lines are in the second period of the experience. And you can see that the number of skin conductance responses on the horizontal axis is inversely related to the scan path entropy. So the higher skin conductance responses correspond to lower entropy, and lower entropy means less surprise. You've adapted, you understand what the environment is. Now I'm going to talk about plausibility a bit. In the bystander study, there was an earlier failure of plausibility in an earlier study that we did, which illustrates the concept. So for example, the first time we tried this study, it didn't work very well because many subjects said, a fight like that would never happen in a bar like this. Why? Because the bar didn't have the kind of decorations that it would be a place where football supporters visited. So we failed on reproducing expectations that people would have for the kind of place where this kind of fight would happen. So plausibility, when you're reproducing something in virtual reality that could happen in reality, plausibility demands domain knowledge, where the situation represents something that could happen. We also carried out an experiment with medical doctors, which also illustrated a failure of plausibility. Medical doctors these days, I don't know if you've been, probably not recently, by the way, but if you've been to a medical doctor, you know they spend a lot of time now looking at their computers rather than at you, the patient. And when we did a study and there wasn't a computer on the virtual desk of the doctors, then they said that this didn't really work for them. So plausibility, though, is a very complex topic. Look at this example. This is a study of fear of heights. So people are standing high up on a building in an atrium, and look what's going on in the atrium. There's a shark swimming around in the open air. Doesn't make any sense. But somehow people didn't reject this. So somehow there can be situations where you can introduce completely wild, unexpected events, but people still go along. They don't lose plausibility. And this is something very complex to understand. So now I'm going to talk about measurement. What are the necessary conditions for place illusion, pi, and plausibility, psi? They're completely computable. As I said, pi is how you perceive, and that depends on what the hardware and software of the virtual environment affords you for perception. And psi is what you perceive, or this is everything there is programmed. So these are completely determined by the physical and computational properties of the VR system. I'm not saying here that this is a deterministic system, that you will automatically get place illusion or plausibility if certain things happen in the program and in the hardware and so on. What I'm saying is that these provide the groundwork, the hardware and software. The program provides the groundwork on which place illusion and plausibility can arise, because there are individual differences between people. So how can we decide on which system configurations might enhance these illusions? So now this moves on to the issue of measurement. So I would say avoid sole reliance on questionnaires. Questionnaires have the problem that intersubjective comparisons of ordinal scores between people are problematic. Physiological responses is another possibility. So you measure people's physiological responses to an environment, but there you need specific circumstances, such as threat, to use effective measures. So for example, what's the physiological response to being in a virtual kitchen where nothing is happening? There's no particular physiological response that you can use to measure place illusion or plausibility. So several years ago, we introduced a psychophysics-based approach analogous to color measurement theory. So the idea of this is that the sensation of red, for example, is a subjective experience. We can't know if different people experience the same sensations, but generally they do agree about what's red. And there's a well-founded quantitative model for color perception based on this. So in this paper from 10 years ago, we showed how a similar technique to color measurement theory could be applied to understand the contribution of 4 factors to place illusion or plausibility. More recently, we applied the same technique to the analysis of factors that contribute to plausibility in the context of a music performance scenario, and I'll show you this in a few minutes. And in Skarbez's 2017, we again examined plausibility with respect to virtual character behavior. So the idea is this: in color physics, we have the spectral energy distribution function C lambda, where lambda is the wavelength, and this is the physical basis of color perception. So different surfaces emit or reflect colors, and this is based on this wavelength distribution, C lambda. So my argument is that C lambda provides the physical basis of color perception, just as our immersive system, the hardware and software and the program, that provides the physical basis of presence. But C, this wavelength distribution, isn't itself color. Color comes from how our perceptual systems respond to the wavelength, and immersion in itself is not presence. Immersion just provides the foundation for presence. So in color theory, what happens is you have a target color that an observer looks at, and then the observer can manipulate 3 projectors, red, green, and blue, which mix together, and that the observer can manipulate the amount of red, the amount of green, the amount of blue, until they say, yes, to me, the color I've just made matches the target. So you average this over many people, and you get RGB values for the target color. So now I'm going to show how we use a similar idea to look at the plausibility of a string quartet in virtual reality. So we had, first of all, a target level of plausibility, which is that we had 4 factors and we played them all at the highest level that participants experienced for a couple of minutes. And we asked them to remember how real this felt to them. And then we start the sequence again at a low level of all the factors, and they can manipulate 4 different things. First of all, gaze, whether the players of the string quartet are looking at the participant or not. The sound spatialization, is it mono, stereo, or spatialized? The auralization, is it dry, large, or real? And the environment, is it none, or are there sounds coming from the outside? And at various points in the unfolding of this virtual reality sequence, participants can choose to do a transition from one configuration of these factors to another one. So here's how it looks. Oops, sorry, just go back, play this. I'll wind this forward. Obviously, you can't hear this. It's best with earphones. You can't hear it as it's supposed to be heard. So for this, we use the body tracking suit. This was an NVIS head-mounted display a few years ago. And then the participant can alter different aspects of the configuration. And the things they could control were the avatars of the musicians, looking at them or not, the sound spatialization, the sound auralization, and the environment sound. And this is what you're going to see from the perspective of a participant. And so it goes on. So in this study, there were 20 participants and they were recruited from our university campus. And there's 36 possible configurations which they can step through. 2 levels of gaze, 3 levels of spatialization, 3 levels of auralization, and 2 levels of the environment sounds. And the participant at various points chooses transitions from one configuration to another. And there are various constraints on these transitions that I don't have time to go into. So the participants, first of all, had training, 2 minutes at the highest configuration. Pay attention to how real this feels. And then they did 5 trials, each starting from a different low-level configuration. And this is the critical thing. They were told, stop when you get a match between your original feeling of plausibility and the feeling that you have now. So what you've got is, for every subject, you've got a whole sequence of transitions they made from one configuration to another. And if you take all the data together, you can form a Markov probability matrix, which is the probability that if at time t you are in configuration I, then at time t plus 1 you're in configuration j. And this is the probability Pij. It's a Markov probability matrix. And if we have U as a vector of initial probabilities of all the configurations, then U times P to the power of K gives you the probability of being in the various configurations after K transitions. And so the particular configuration of interest is where you start with all the factors at their lowest level. And then when you go through U times P to the power of K, you get the subsequent configurations after 1 transition, 2 transitions, and so on. So from this, you can work out various probabilities of interest. You can say, what's the probability that if you're in a particular configuration, you'll find a match? That's a match between your current feeling of psi and the original one you had when everything was at the best level. Or you can look at it the inverse way. Given that I've experienced a match, given that a subject has found a match, what's the probability that would be with a particular configuration? You can work out all kinds of marginal probabilities, like, for example, the probability that given that you found a match, that match includes stereo. So what we found is that starting from lowest level configurations, the highest probability transitions are 1, activate the environment. There was a door to the outside in that virtual room where birdsong and wind was coming in. They wanted to hear the birdsong and wind. And second was make the characters sometimes look at you. This was the second most important transition that we found. By transition 5, the probability of setting auralization to its highest level was more than double that for spatialization. So we can have a look at this way. This is the probability that for every configuration that you would find a match. Well, not for every configuration, for the highest ones. So we see the highest probability when there was gaze, the characters were looking at you, when there was stereo sound, when there was real auralization, and when there were outside sounds. Another way to look at this is that, remember, gaze has 2 levels, 0 and 1. Spatial has 3 levels, oral has 3 levels, environment has 2 levels. if we look at these probabilities, we see the probability that a match contains gaze at level 1 is 0.91, and the probability that contains environment at level 1 is 0.97. Note, there's been no questionnaires here at all. This is all simply based on transitions that people chose. So the most important factors will gaze towards the participant, and this fits with plausibility that events and actions relate personally to the participant, and environment sounds from the outside, and that coheres with what would be expected with the open window, or in fact the open door to the outside. Oralization, though, corresponds to what would be expected. The reflections correspond to the room size, but spatialization is more important for place illusion. It's a sensory motor contingency that helps to locate the participant in space. It's interesting that this method naturally gives rise to equivalence classes, which are sets of configurations with more or less the same probability. Like, for example, those 4 have more or less the same probability. Those 2, the same probability, roughly, and similarly those. And so what this means is that if this were known to engineers, they could use trade-offs between the different configurations and say, okay, these 4 all have the same probability, more or less, so I'm going to choose the one to implement, which is the cheapest one. We did another study. I joined together with some people from Facebook where an avatar gave a talk it was a real TED talk, and they were interested in how to give talks in virtual reality. And there were 4 factors that we looked at. Eye gaze, which all had 3 levels. Eye gaze, eye blinking, mouth animation, and micro expressions. This was just recently published in IEEE VR. And there were 55 participants. Each transition, here we used a budget. So in order to stop participants just choosing everything at the maximum straight away, each transition had an associated cost. And we didn't try to maximize pi or psi. They were told conserve their budget, but choose the configuration that you prefer for whatever reason. We didn't impose a reason on them like place illusion or plausibility. So here's how this looks. Whoops, sorry, once again, I have to go back. Okay. So this is the idea that first of all, subjects are taught how to change the configuration.
Welcome to the demo experience.
So notice there's no mouth movement here. And then when you change the mouth movement, this starts. So this is the actual talk.
Have you unfriended someone on social media because they said something offensive about politics or religion, childcare, have someone fighting both passionately for it and against it?
They're witnessing a talk. And then every so often they get the chance to change something. Here, they're changing mouth movements, and then they continue.
Research did a study of 10,000 Americans we failed to teach.
And then now there's mouth movements. If I wind this forward a bit, again, now they're making another change, and so on. So it played out for a few minutes, and every so often they could make a transition. So what we found is that, for example, again, there's no questionnaires here. It's all based on transitions. After 7 transitions, the configurations will contain the factor at the given levels. So, for example, remember there were three levels of each factor, level 0, 1, or 2. So if we look at blinking, the probability is that after 7 transitions, the probability that they would have chose blinking at least at level 1 was 0.90. The probability they would have chosen mouth at least at level 1 was 0.97. And this had a nice test in it because actually eye blinking at level 2 was the same as at level 1. And if you notice on row 2 here, the subjects did not tend to choose eye blinking at level 2 because they found no difference between that and level 1. So this was like a kind of a placebo test. So to wind up the discussion on measurement, questionnaires are useful, there's no doubt about that, but you can't do a lot with them because you can't combine scores mathematically. They're ordinal scores, although many people do treat them and do t-tests on them and so on. So just as in color science, just as color science relies on the agreement of what red is, but without ever needing to know how any particular individual judges or what kind of feeling they have about red. We never ask people, how red does this seem to you? We only ask them to judge, does this match the other color? So our method here relies only on the fact of participant choices, their transitions, and only on the fact that, okay, we've reached a stage that we're happy with. And by the way, if you had k binary factors, like in the last experiment, we had 4 factors each at 3 levels. But if you have k binary factors, then if you wanted to carry out a classical experimental design to test which combination of factors was best, you need 2 to the power of k conditions. So my conclusions on presence is presence as being there, place illusion. There's been a huge amount of research in the past 30 years and the outlines of a theory exist. Plausibility is a much more difficult problem with relatively little research, but plausibility is essential because if people lose plausibility during the course of experiencing their application, they just lose interest in it. They just ignore events. So plausibility is needed for effective applications. Now I'm going to move on to the last illusion, which is body ownership. So a body ownership illusion usually occurs when there's multisensory data that involves a contradiction. The brain resolves by producing the illusion. And a good example of this is the Pinocchio illusion. Here the subject is the one sitting behind, and the one in front is needed only for his nose. The subject has his eyes closed. The experimenter is tapping the nose of the subject and synchronously moving the subject's finger to tap the nose in front. So from the point of view of the subject, they feel their nose being tapped, and they are tapping a nose. So the brain doesn't like confusion. It merges these into one overall perception, which is that I'm touching my nose. But it doesn't make sense because the hand is outstretched. So what solution does the brain come up with? It comes up with this solution, that the nose is very long. This is impossible to describe. You have to experience it. And if during your lockdown there's 3 people in your home, you can actually try out this experiment. It doesn't work on everybody, but it works on most people. Here is a more well-known example called the rubber hand illusion. The hand on the right is the person's real hand that they can't see. The one on the left is a rubber hand. The experimenter synchronously tapping and stroking the real and rubber hand. And after a while, it feels like the rubber hand is your hand. And if it's attacked, you respond. It's a very strong illusion. This is what I mean by multisensory integration. So how do we do this in VR? We can use visual tactile synchrony like the one you just saw, but we tend to use more visual motor. Here, the person, when they look down, they see a virtual body substituting their own. When they move, it moves with them. They can see it by directly looking at themselves and also in a mirror. This typically gives rise to a strong illusion. This is my body. So it's been shown many, many times over many years that this illusion of body ownership exists. But what's more interesting to me is that there's correlates of having an altered body. So several examples have shown that when you change someone's body, you change aspects of the mind. And we've used this in studies on racial bias, an adult becoming the child, illusory agency, that is, you have the feeling that you did something. Actually, it was only your virtual body that did it and not you. Motor activity can change. When you have a different body, you can have less pain when you have a virtual body. You can get cognitive changes, and even, as we'll see, it can influence fear of death. So one study we did, I don't have time really to go into hardly any of the studies we've done, but one which is quite interesting is we found that being embodied as Albert Einstein improves performance in a cognitive task. This is for people with low self-esteem especially. And that's compared with being in a different body, which is a younger body that look more like the real person. So in this study, again, people were given a cognitive test before the VR exposure. Then they went into the VR embodied either as Einstein or a younger body. And if you look at the top graph, you can see that the D score, which is the change in score of a cognitive test afterwards minus before, increased for those in the Einstein compared with those in the normal. But if you look at the bottom graph, that increase was far more important for those with low self-esteem than for those with high self-esteem. The bluish colored ones are the ones for low self-esteem. The ones for high self-esteem, there wasn't really much change. So it's like saying, oh, I have low self-esteem, I don't think I'm any good at these kind of tests. When you're in the body of Einstein, somehow something changes and you perform better. If you already have higher self-esteem, then being Einstein doesn't seem to help much. Now I'm going to talk about one called near-death experiences, and actually rather than describe all this, I'm just going to play a video. So therefore we had the idea that in immersive virtual reality we could actually put people through experiences where, for example, one, they can have the illusion of being separate from their physical body, actually have that experience. And second, that it would be possible to put them through a whole cycle of birth, life, death, and yet nevertheless survive that death because, of course, in physical life they are alive. So in other words, they enter a virtual reality, they have a whole experience of, over several sessions of being born into a virtual reality environment, interacting with other people, growing, maturing, eventually growing old and dying, and they come out of the virtual reality, but yet they're still alive. So it occurred to me, the brain may unconsciously take this as a kind of model of how our own existence is, because maybe when we die we go to another plane. I'm not saying I believe this, but I'm saying this is the model which we were interested in having people experience that just like in the virtual reality, when they, in quotes, die in the virtual reality, they're nevertheless still alive in this other plane, our real world of existence. So possibly our real world of existence is like the virtual reality, and when we die we go to some other plane and we can look back on this life as like a virtual life. So this was what motivated me to be able to use virtual reality to explore in a scientific way these very, very interesting and obviously life and death situations. That what happens in this experiment or this study that we're doing is that there are always three people simultaneously in a virtual world, which is a kind of beautiful island where these three people, they see virtual representations of each other, and each person can see their own body, so they can look down towards themselves and see a virtual body that substitutes their real one, or in a reflective surface they would see their virtual body, and they see the bodies of the other people. These three people, they don't meet physically, they only meet in the virtual reality where they see each other's representations, and they can't talk to each other, but they can wave, they can call each other, they can point, and they can make any gestures with their real body which are reflected in movements of their virtual body. So they have this experience of working together in a number of tasks with the two other people. Each three-person unit has to carry out some tasks. And over time, they see actually both of the others gradually mature, grow old, and then one of them dies. And then the next time, another one of them dies. And then eventually, each person has this experience where they die, they see themselves from above in like an out-of-the-body experience. So they see their previous body immobile, old and immobile and dead from above in an out-of-the-body experience. And then they have a simulation of what we've learnt in the literature has been called a near-death experience. So they go through a tunnel of white, they go through a tunnel, they see the white light at the end of the tunnel, and when they get to the other end, we take them out the virtual reality, and of course they're still alive in physical reality, and then they can look back on a screen at their previous world. They can see their previous world, and they would see the other two people doing a memorial for them. So they've had this whole process of being born into.
Solemos decir que de la tierra venimos y a la tierra volvemos. Y entonces, cuando vi lo del árbol, fue como que noté el mundo virtual, que no es así, pero lo noté como creado para mí. Sí. Yo tuve la teoría, teníamos un diario en el que teníamos que ir escribiendo todos los días. Y yo empecé, cuando murió el primer avatar, dije, no me gustó y dije, bueno, voy a empezar a memorizarlo todo por si hay algún indicio que me indique que yo voy a morir. Y entonces empecé a fijarme todo en el ambiente, en los avatares y todo, ¿no? Y entonces empecé a darme cuenta que la evolución del cuerpo estaba relacionada con la muerte.
So in this experiment, we embodied people in a shared virtual reality for 6 days, 30 minutes at a time. There was very strong social presence and body ownership. People had strong sadness on finally leaving the island forever. Compared to a control group, we found that the experimental group reported attitude changes. They had greater interest in global issues. They were more caring for others. They were less interested in the material aspects of life. And these are many things that are reported for real near-death experiences. So my conclusions. Presence, place illusion, and plausibility are unique illusions that can be generated in immersive systems. Body ownership illusions are straightforwardly realizable in virtual reality, and these are very practical illusions. People respond realistically, and they're really important for applications. I think that in the coming years, we'll see applications of these techniques to self-transformation, including medical and psychological. This is why we made our spin-off company, Virtual Bodyworks, because we were doing work in the university sector that we couldn't possibly exploit from within the university. My own interest in virtual reality has always been to go beyond it, not using it simply as a simulation of reality. So in virtual reality, we can have impossible but real beneficial experiences. So for example, when I have a problem, I can talk to, for example, Steve Jobs about it using embodiment. And I had a problem in the preparation of this talk. And to conclude, and as a kind of summary, I'll show you what happened.
Look at your right hand. Look at
This
your
is
left
me
hand.
embodied with a quest.
Now look in the mirror to your left.
This is me with my
Raise your
pre-lockdown
right
haircut.
arm.
So this is a
Raise
period
your
where I'm
left
just
arm.
becoming embodied.
You can now put your arms down.
The other side is Steve
When
Jobs.
the light next to you turns green, explain the challenge to the person in front of you using your own words. When you have finished speaking, press the button by your index finger. Please look down towards
Now I'm
your
embodied
body.
as Steve Jobs.
Now look in the mirror to your right. Now listen to the person in front of you, and when the light next to you turns green, reply and try to help them find a solution. When you have finished speaking, press the button by your index finger.
Hello, Mr. Jobs. Thanks very much for seeing me. I know you're very busy. What I wanted to talk about is that this week I have to prepare a talk for QoMEX 2020. But last week I gave a talk which several thousand people seem to have watched And I'm worried about overlap between the talks and me just giving the same thing over again.
Hi, nice to meet you. But come on, man, are you telling me you've got nothing else to talk about after all this work and all these years? Come on, think about it.
Well, I guess you're right, because like I didn't really talk about present. I didn't talk about measurement. We've done several experiments on body ownership, but I didn't talk about, well, actually, I remember we did the one on fear of death. I haven't talked about that hardly. So yeah, maybe I can come up with something.
Fear of death? You really want to go that far? Okay, but man, it's up to you. Anyway, I think we've said enough and we can finish now if that's okay with you.
So there are many people in my lab who are behind all this work. These are people either pre or present members of the lab who have contributed in various ways to what I've talked about today. And almost all the funding for this is from European Union and mainly European Research Council. So thank you very much for listening, and I guess I'll be answering questions soon.